Okay, so here I've got a question about, it's a Gibbs free energy varying with temperature, so it's a graph. If we remember the straight line relationship y equals mx plus c, we can apply that to this. Looking at the graph, we can see that delta G is down the side here and it's in kilojoules per mole. Excellent. We can see that the temperature is across on the x-axis here in Kelvin. Okay, so write an equation to show the relationship between delta G, delta H and delta S. So this is a really easy start to this. We just have to remember that relationship. Delta G equals delta H minus T delta S. Okay, it says use the graph to calculate a value for the slope, the gradient of the line, give the units of this slope and the symbol for the thermodynamic quantity. Okay, so we'd have to remember the straight line equation y equals mx plus c. And if we put this into a straight line relationship that follows this, this is delta G equals, here we've got the mx plus c part, so this would be minus T delta S plus delta H. Now just to remind you, delta H corresponds to the intercept, delta G corresponds to the y-axis, so there's the y-axis. The x here is the temperature, so x is T, so the gradient is m, and in this case it's minus delta S. So m equals minus delta S and c equals, or is the equivalent of, delta H in this relationship here. Okay, so we can use that here. Okay, so the gradient, so minus delta S equals, and it's going to be the rise divided by the run, or the height, or the change in the y-axis divided by the change in the x-axis. And I always like to pick up something that's fairly easy to read. I'm going to read from here, I think. So this is 2, 4, 6, 8, 10. So each of those squares is 2. This is 42, 43. So that is 43. And if I go all the way down to here, that is at that's minus 22, minus 22. So minus 22, so that's at plus 43, that's minus 22. So that is a distance of 43 plus 22, 65. So that's 65 a distance, and we're going to go over this value here. This is at that point, and this is at 900, so that's 900. This is 200, 20, 40, 60, 80, 300, so that's 240, so that's 240, and that's 900, so that distance there is 900, take away 240, which is 660, so that's 660 there. Right, so I can work out that gradient. So 65 divided by 660 equals 0.098. I'm going to take it to 3 figures, 5. So minus delta S is 0.0985. So delta S equals minus 0.0985. Okay, and that the units at this stage are kilojoules per Kelvin mole to the minus 1. So it says give the units of this slope and the symbol. So there's the delta S, there's the units that I've worked it in, and there's the it's a negative. Okay, right, explain the significance of the temperatures below where the line crosses the temperature axis. Okay, so what can we say? So as it's below the temperature axis, what can we see about the delta G? The delta G is negative, so if delta G is negative, the reaction must be feasible. So below delta G, below so delta G is negative when the line crosses the temp axis. I'm going to actually say what that temperature is, and it crosses at that point there, which is 420, 40, 60 at 460 Kelvin. Therefore, the reaction is feasible below 460 K. Alright, so that's the answer to that. So if the delta G is negative, the reaction is feasible, and so the reaction becomes feasible at that temperature or below. Okay, so delta G is 0. The line is not drawn below a temperature of 240 because its slope or the gradient changes at that point. So we're going to be looking at a gradient that changes. Maybe it goes like this, or maybe it goes like that, but it changes. Why does the change happen? Okay, so just what happens to the ammonia at 240 that causes the slope to change. 240 is actually a low temperature. We know that room temperature is 298, 0 degrees C is 273, so 240 is actually quite a low temperature. So that's a negative Celsius temperature. So probably what's happening here is, as we can see, ammonia is a gas at room temperature. If it changes slope, what it's saying is the entropy is changing. So here we've got a certain entropy, the entropy is increasing, but as we change its slope, we're changing entropy. So it's probably going from a gas to a liquid. So the ammonia changes from a gas to a liquid, so the entropy will change. At 240 Kelvin. Okay, 240 Kelvin. That will answer that question there.